Hello, hello, hello! 10.1 lines and segments that intersect circles. Chapter 10? What? Chapter 10? Chapter 10 is on cycles. Yep, cycles. Chapter 10 in your notebooks. In your books of note. First, we have to talk about what is a circle. So in your notes, just all this stuff on page 530, put this in your notebooks. A circle is a set of all points in a plane that are equidistant from a given point called the center. So there's an example of a circle. A circle, the center is P, so you can write that like that. That right there means circle P. So that little symbol right there, boom. Okay, now, segments whose endpoints are on the center and any point in the circle is a radius. There's an example of a radius, that one in red on page 530. So the one that's a chord, here, I'll do this. This you can see easier. You can see this. A chord is a segment whose endpoints are on the circle. So that right there, AB, that is a chord. Okay, just AB, that's a chord. From A to B, that's a chord. A chord that goes to the center of the circle. P is the center. That right there means circle P. That means P is the center of the circle. This chord goes to the center of the circle, EC. It is a chord, but it's a special chord called the diameter. That's a diameter. Okay. PD, that, excuse me, PD is a radius. It goes from the center of the circle to any point on the circle. So PD is a radius, P to E is a radius, P to C is a radius. Okay. Then we have, paper getting stuck. Here we, can I see that right there? On my, so, yep, we can see that. This right here, here's a line. There's a line that touches the circle once. This line is called a tangent line. Line ZY, that line is tangent, and the point of tangency, it touches the circle once, that's called the point of tangency. Okay? Excuse me. This one right here, line TV, this is a line that intersects the circle twice. That's called a secant. A secant. This is a tangent. Tangent. Wait, what? Last chapter, tangent meant something else. Opposite over adjacent. You're right. Now, this line is tangent to the circle. Same word, different meaning. What? I know. So a tangent, a line that intersects the circle once is called a tangent. A line that intersects the circle twice, right there and there, is called a secant. There's no such thing as a secant. It's a secant. Secant. Okay. If a line like this does not intersect the circle, let's call this AB. Here's line AB. It does not intersect the circle. What's it called? A line. It's just a line. Okay. Next, in your notebooks, we have, here we go. This is on page 531. Okay. Coplanar circles and common tangents. In a plane, two circles can intersect in 2 points, or 1 point, or no points. Okay. Here's two circles that do not intersect at all. Here. These two circles do not intersect at all. These two circles intersect at 1 point. These two circles intersect at 2 points. These two circles intersect at 1 point. They intersect at 1 point. Okay? 1, 2 points right there. 1 point, no points. Now, coplanar circles that intersect at 1 point are called tangent circles. Coplanar circles that have a common center are called concentric circles, like this. That right there, like, is similar to a target. Those are concentric circles. Both of these circles have the same center. It's just that the circles have a different radius, different radii. Just one circle is bigger than the other. They have a whole bunch of circles. It looks like a target. Okay, so in this case, you cannot, here's a line that's tangent to both circles at that point right there. That line is tangent to both of those circles. In this case, this line is tangent to both those circles at this point. They have a common point of tangency. That one point, you can get a line that's tangent to both circles. That one point is tangent, a line that's tangent to both of those circles. You cannot have one line that goes through those 2 points and is tangent to both circles. It's not going to happen. Okay? So, a segment that is tangent to 2 coplanar circles is called a common tangent. So something like this, how many tangents can you get? So, can you see that right there? Yes, you can. So, there's a common tangent. That's a common tangent. There's a common tangent. And there's a common tangent. 4 tangents. 4, count them, 4. Now, if I connect a segment from center to center, if the tangent passes through that segment, it's called internally tangent. So this line right here is internally tangent because it crosses that segment. This tangent also crosses that segment. So this line is internally tangent. This line is internally tangent. This line doesn't cross that segment, from a line segment from center to center. So this line, since it does not cross that segment, that's a segment, not a line. This tangent is externally tangent. This tangent is also externally tangent. What about this one? How many tangents can you get? In this case, you can just get one. Whoops, let me use that color. Zoom. You have one tangent. Is it internally tangent or externally tangent? We'll draw a segment from center to center. Did this tangent cross that line? Yes, so it's internally tangent. It's internally tangent. What about this one? We have a tangent that goes, oh, I can't even see there it is. So that, boom, it's tangent to both circles. That is tangent to both circles. Does it cross that segment? No, it does not cross that segment. So that is externally tangent. That is externally tangent. What about in this case here? In this case, boom. Does it cross that segment? Nope. So that's externally tangent. That line is tangent to both circles. Okay. Boom. Boom. Next, tangent line to circle theorem. So here we have, this also needs to go into your notebooks. This stuff here on page 532, both of these. And what that means, right here, if this line is tangent to the circle, it means it's going to touch that circle once, and that where it touches, that is called the point of tangency. If you draw a line from this point to that center, that's a radius. If you draw a radius to that point of tangency, that will be 90 degrees. Okay? In a plane, a line is tangent to a circle if and only if the line is perpendicular to a radius of the circle. Okay? If that's 90 degrees, that means that's tangent and that's a radius. The next one, externally tangent congruence theorem. So, these on the, there we go. In this case, tangent segments from a common external point. Here's a common external point J. So there's a tangent JH, and here's another line that's tangent JK. JK. Okay. In this case, since they meet on the outside of the circle, that means distance JK and distance JH are congruent. Same distance, they're congruent. Okay. Boom. Now let's start getting to some problems. Here we go. You're gonna have to name a circle, name 2 radii, name 2 chords, name a diameter. This is all stuff. Question 11. We did stuff like this, internally tangent, externally tangent. We did that. 19, let's go to 19. Ooh, I got a question for you about a circle. Okay, true or false? True or false? Okay, whoa, how's that? True or false? A circle is a set of all points that are equidistant from a given point called the center. So again, is this statement true or false? A circle is a set of all points that are equidistant from the given point called the center. That statement is false. You need to rewind this tape and listen to what I said. I will say it again this time, so it's true. The circle is a set of all points in a plane that are equidistant from a given point called the center. I will say it again. This one's going to be true. A circle is a set of all points in a plane that are equidistant from a given point called the center. If you rewind and listen to the first two are incorrect, the last 2 are correct. The last 2 are correct. It refers to a circle. The first 2 refer to a sphere, a ball. So be careful of that. Be careful. Be very, very careful. Thus, okay, right here, 19B. Numbers 19 through 22. Tell whether zx, in this case, that distance. Tell whether this. No, sorry. Tell whether this distance right here is tangent to circle. Again, in this case, it's circle Z. Is this segment going to be tangent to that circle? Explain your reasoning. So that distance is 6 units. Let's make it meters. 10 meters to 8 meters. Is that going to be tangent? Well, if it's 90 degrees, that's going to be tangent, but how do we know it's 90 degrees? Hey, right triangle. Good thing we can cover right triangles. Hey, if this is a Pythagorean theorem, the longest side, which one's the longest? That's the longest side. If there is going to be a bigger angle in this thing, it's going to be, this is the biggest side, so the biggest angle has to be right there. If that's 90 degrees, that means 6 squared plus 8 squared. These are the 2 legs. This is the longest side. That would have to be the hypotenuse if it's true. If this is a true statement, that's 90 degrees. If that's a false statement, that is not 90 degrees. Okay? So you just have to find out if that's true or not to figure out if that's true, that is 90 degrees. If this is a false statement, if it's false, then that's not 90 degrees. I'll let you figure that out. Excuse me, Pythagorean triple. Question 23C. Okay? Question 23. So, in this case, circle C. I'm looking at 2 different things here. Circle C, there's your center of the circle. Okay? This. This is the point of tangency right there. So that's going to be 90 degrees. That means that line is tangent. Find the radius R. Find R. Ooh, there's more than one of them. What does that mean? It's a pirate time. R. God, that's a bad joke. How do you do this? Ooh, we have a right triangle. We can use Pythagorean theorem. This distance squared plus that distance squared equals this entire distance squared. How do you do that? Well, put it on a piece of paper. Piece of paper. R squared plus 24 squared equals, how do you do that? That quantity squared. That's how you do that. Okay. 24 squared is 576. And this squared is, you're going to have 2 of them. Okay, we're going to go this times this and this times this. And we also have this times this and this times this. 16 times 16 is 256. 16R, 16R, and R squared. So now it looks like that. Boom. We have this right here. Hey, we can subtract R squared on both sides. I'm going to subtract 256 on both sides of the equation. These are like terms. We can combine those two. So r squareds cancel. This cancels out that. So the only thing on the right side is going to be 32r. On the left side, it's a 0, it's a 2, 320. So now we have this. Now what? Divide both sides by 32, 32, and our 10. Boom, done. No, we aren't. Is it meters? Is it miles? Is it feet? Is it fried green tomatoes? Is it freshmen? Is it adults? It's units. People will keep on making these mistakes over and over and over, and you will keep on making these mistakes until you lose points on a quiz or test, and you're finally going to realize, oh, I better put that down. So I stop losing points. Okay. Next, 29b. 29b. We have points. These points, these lines are tangent. Where are we? There we go. This line is tangent to the circle right there. That's the point of tangency. That line is tangent to the circle. Point D is a point of tangency. This is circle K, so that means that's center is K. Circle K, the center is K. We have to find all values of x. Well, hey, if this tangent and that tangent meet at a point outside, that means this distance is the same as that distance. Hey, 2x squared plus 4 equals 22. We can now set up an equation. So, set that up. There equals 22. Subtract 4 on both sides. We got that. Then what? Divide both sides by 2. They're saying this is really important stuff. That's what that siren means. Either that or my ride's here. What do you do now? Take the square root of both sides. And the answer is, what's the answer? I'm going to bet most students got this wrong. Ha! Yeah, that's what most students got. And you'd be wrong. Say plus or minus 3. X is plus or minus 3. So the distance is going to be some units. So this x is just a number here. It's plus or minus 3 because x could be a positive 3 and it'd be equivalent. X can be a negative 3. They would be equivalent. This is a distance, so the distance itself would be units. But 3, in this case, you don't need units in this case. To be on the safe side, just put units. That covers your butt. X equals plus or minus 3 units. Boom. Question number 37 bis. 37 busy as a bee. Each side of the quadrilateral is tangent to circle R. So tangent, 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 tangent to SVQH. Find the perimeter of the quadrilateral. So these are all tangents. So that's a point of tangency. There's a point of tangency. That's a point of tangency. That's a point of tangency. What? How do you do that? The same way we did this one. What? We're going to use this rule right here, this theorem that we learned earlier. Hey, this distance is the same as that distance. What? That's 2.4. These two tangents meet at a point V. That means this distance, the same as that distance. They're both 2.4. These two tangents meet out here. That means this distance is equivalent to that distance. They are equivalent. That's 3 meters. They're also 3 meters. Hey, these two tangents meet at a point outside the circle. That distance is the same as that distance. 1, 2, 3. 1, 2, 3. So if that's 2.4 meters, this is also 2.4 meters. This is a tangent meets outside the circle at H. That tangent also meets at H. So that distance and that distance are the same. Well, Oh, that whole distance is 9.3. That's 2.4. What's 9.3 minus 2.4? 27.3? No kimosabi. 9.3 minus 2.4 times the calculator, you get 79.643. 6 meters. So this distance is 6.9. That distance, 1, 2, 3, 4, same distance, is also 6.9. So we have 6.9 plus 3 plus 3 plus 2.4 plus 2.4 plus 2.4 plus 2.4 plus 6.9. That will be your perimeter. I'll let you figure that out. Beautiful. That's it, guys. Hasta bye-bye. You should get a calculator. Get a calculator. It's going to make your life easier.